welcome you to this particular topic. It's going to be the last topic in the semester. Okay, so I share this material the other time, so going to be walking you through the material. If you want to solve an integration problem, okay, like the one that is being displayed, okay, we got a rule. Okay, so the rule is going to be if I have integral s raised to power n dx, okay, where n is a constant, it's actually going to be this divided by that plus constants. Okay, so whatever you have, okay, it's always, that is the way it's going to be. That's the way it's going to be. So let's take a look at what I have right now. Okay, so it means if I have integral x raised to power 7 ds, that's going to be x raised to power 8 divided by 8 plus constant. And that's exactly what it means. So so that is a general rule, for that. Okay, so when you take a look at this guy now, if I want to integrate that guy, what I'm actually going to write, I've first write negative 24 is going to be outside the integral. I'm left with this. So, if I write that now, I'm actually going to have s to the power 6 divided by 6 plus constant. So 6 goes in that. I got minus 4. Okay, x raised to the power 6 plus constant. So I'm done. Okay, so that is how that's going to be solved. It's as easy as that. And I'll worry about situation whereby I actually um, want to integrate a constant. If you take a look at this problem right now, this is independent of x. Okay, so what I'm just going to do is to rewrite this as negative 3 s raised to power 0 ds. Because s raised to power 0 is actually 1. And 1 times negative 3 is going to be negative 3. So bringing negative 3 out, I'm actually going to have this. Yes, so if you want to go by the way we've been doing it, it's going to be 0 plus 1, right? Divided by 0 plus 1 plus constant. And that's going to be negative 3 x over 1 is that. So I'm actually going to have a negative 3x plus c. Okay, so that is how that is going to be solved. Okay, so if I want to go to the third problem now, okay, on integration, don't forget integration, we also call that antiderivative. So if I come to these two questions now, they're going to be easy, right? Question 3, question 4, right? So take a look at question 3, okay? You look at question 4, you're actually going to solve that. So similarly, it's going to be negative 6x squared over 2 plus c. By the time you factorize, you get this guy. And right here, you got 12 into integral s squared ds. So which is going to be 12. Okay, 3 divided by 3. What's that? So 3 goes that. It's going to be 4 s cubed plus c. Okay, so that's how that's going to be solved. Now, in a situation where you have, if you look at equation 5 and 6, where we actually have a linear combination, right? Okay, we're just going to find the antiderivative one at a time. For instance, if you take a look at question 5, okay, because you look at question 5, do you know I can write this as this, okay, minus, okay, integral 10x dx. I can put it on the separate integral. So here I'm actually going to have 24 x 6 over 6. Okay, minus 10 s squared over 2 plus constant. All I'm just going to do is to start simplifying that, right? It's going to be minus 4x to the power 6 minus, if you take a look at that, minus 5x to the power 2 plus constant. So you're always going to add a constant c whenever you perform an antiderivative. Okay, so antiderivative or without a boundary. Okay, this is what we call indefinite integrals. Okay, indefinite integral. Indefinite integral because if you take a look at the integral sign, there's no lower limit, there's no upper limit. So that's why the final answer is going to be in terms of c. Or you can actually try question 6 on your own. So it's actually going to go the same way. Okay, so what if in a situation where you want to perform an antiderivative on, you know, a function that has a negative power? If you take a look at question 7 and 8. Okay, so let me work with 8 so that you can decide to work with 7. So right here, I'm actually gonna put a negative 2 outside, and I'm gonna be left with this guy, 2x. So what I'm gonna do now, so it's gonna be negative 3 plus 1 divided by negative 3 plus 1 plus constant. Don't forget that. All I just need to do is to simplify. So I'm gonna simplify now. I'm actually gonna have a negative 2 x to the power negative 2 because negative 3 plus 1 is going to be negative 2. Then divided by negative 2 plus constant. Okay, so negative 2 cancel negative 2. I'm actually going to have this plus c. Or I can rewrite that as 1 over s squared plus c. So it's the same. So that I leave my answer in this form. And I leave in the other form. So every other one actually makes sense. Okay, so you can try question 7 yourself. Okay, it's actually super cool. It's super easy. Okay, if you can try to go the same way. Okay, so question 9 and 10, let me try question 10. You can try question 9. Okay, if I want to work on 10 right now. Okay, if I want to work on 10 right now. So it's going to be negative 4 x raised to the power negative 3 plus 1 divided by negative 3 plus 1 minus 20 negative 5 plus 1 divided by negative 5 plus 1. Then finally, you're going to put a constant c. So that's going to be what? Negative 4 here, negative 3 plus 1, negative 2. So you're actually going to have 2 raised to the power that. Okay. Here, that's going to be negative 4, right? So negative 4 goes in negative 20. That's going to be 5, right? X raised to the power minus 4 plus c. So if you want to write that, you can do 2 raised to the power s squared plus 5 raised to the power x raised to the power 4 plus c. Okay, so we should actually solve the problem. That's how we do it. Okay, that's how we do it. That's super cool, right? Okay, so okay, I'm actually gonna go to the next question. Now, when you take a look at question 11 and question 12, I'm actually gonna attempt one so that you can decide to make attempts on the other. So I'll give you 1 second. So I want to attempt on question 11 right now. Now, whenever you see a question in this form, we're actually going to rewrite that as negative 4 x to the power negative 3. Because when you have, if the denominator of a fraction has a positive power, the moment you convert it to numerator is actually going to have a negative power. So here, I'm actually going to have positive power, so it's going to become a negative power. Okay, and I want to do the x. So if I want to go by what I did the other time, I'm actually going to do this. Negative 3 plus 1 divided by negative 3 plus 1 minus 8 s to the power negative 5 plus 1 divided by negative 5 plus 1, okay, plus c. So right now, it's going to be negative 4, right? It's going to be negative 2. So that's going to be 2, right? It's a power negative 2. Okay. And here, the denominator here is negative 4. So that's going to be 2, right? S to the power negative 4 plus c. So if I want to rewrite that, I can do 2 over s to the power 2 plus 2 over s to the power 4 plus constants. Okay? So that's how to do that. That's super cool, right? Okay, so that's how to do that. Okay, so since you already know how to go about all of that, I'm actually gonna go to the next question. Okay, so if you take a look at question 13, where you have x to the power 5 over 2, you're also gonna go the same way. But before you're gonna do that, you can for simplify that and put that outside so that you're gonna be left with that ds. So you're gonna have the negative 7 s to the power 5 over 2 plus 1 divided by 5 over 2 plus 1. So which is gonna be of 5 over 2 plus 1 is gonna lose, I think it's 7 over 2. Okay, it's gonna be 7 over 2 divided by 7 over 2 plus constant. So what you're gonna do right now is actually to simplify. I can write that as 2 into negative 7. Okay, 2 into negative 7. Okay, divided by 7. Okay, x to the power 7 over 2 plus c. Okay, so when I have that, it is gonna cancel that. I'm only gonna have negative 2 s to the power 7 over 2 plus c. Okay, so which is gonna be the final answer to that. Okay, I think so far so good. If you take a look at all of that, that has been super cool. Okay, so the moment you follow the rule, the general rule, okay, you actually are gonna be fine. Okay, so there are several questions. You can also apply the technique to that. Okay, and in a situation, I think where you have this, if I try to do this, okay, let me try to do question 15 so that you can try question 16 on your own. If I want to integrate this guy, what I'm gonna do, I'm actually gonna put out the constant, right? After the integral, then I'm gonna be left with this in the integral, right? ds. So here now, we should have minus 5 over 3. Okay, integral x to the power 2. Now raised to power. When you have a cube root, it's the same thing as having 1 over 3. Okay, so ds. So if I want to write that, I'm gonna do 5 over 3 integral x to the power 2 over 3 ds. Then I'm now going to apply the rule of integration. So what happened? Before applying the rule of integration, you need to for simplify. That's exactly what I've done. So here is going to be 2 over 3 plus 1 divided by 2 over 3 plus 1 plus c. So all I need, 5 over 3. So if I want to get 2 over 3 plus 1, so that would be 2 over 3, 1 that would be 3, right? That's going to be 2. 1 goes in 3. So that's going to be 5 over 3, right? So it's going to be s to the power 5 over 3 divided by 5 over 3 plus c. Okay, so the 5 over 3 will cancel 5 over 3. Okay, so you're going to be left with just this guy. x to the power 5 over 3. But don't forget that's going to be a negative, right? What is a negative here? So it's going to be negative x to the power 5 over 3 plus c. That will be the answer at the end of the day. So I just wanted to take note of that. Okay, so so far so good. That's how you actually going to integrate perform an antiderivative. Okay, on that it's super cool. Okay, just like what I said. Okay, so I think I put an answer key, okay, in case you want to work them out. Okay, that is your corresponding answers. Okay, they're actually very easy to navigate. Okay, they're very easy to navigate, like I said the other time. Take a look at that. You can decide to try them out. And of course, you are going to see the kind of answers you're going to get. So you can decide to check. Okay, so this is I'm going to go to the another one. Okay, so this is eco material. You're going to apply it the same way. Okay, you're going to go the same way. So you can decide to see how you can go about all this, okay, on your own. But what I'm actually want to walk you through right now is this. We got some basic rule in addition to the general rule of integration. Okay, in addition to general rule. Okay, so if we want to talk about trigonometric, where we have a sine, you got a cos, you got a tan. So we actually get some, standard way, to integrate them. So for example, if I have integral of sine s ds, integral of sine s ds is going to be negative cos x plus constant. That's a rule. Integral of cos x ds is going to be sine s plus constant. Okay? So I want us to, like for instance, if I want to solve that guy now, okay, it's typically just going to be, because integrating sine is going to be negative cos, that's going to be negative 7 cos x plus constant. That's super cool. Okay, it's super easy. So it's super easy because you know the rules. Okay, I think I'm gonna go to um the solutions to that, so that you, like, this is what I'm talking about. You see the sign is gonna be a negative. That's why you see a negative, right? The cos is gonna be a sign. You see that? Integral of cos is gonna be a sign. Okay. But you may be wondering, for instance, what if in a situation where we got a multiple angle, like how do they, for question 15? For question 15, what you're actually going to do if you really want to integrate that. Like I want to integrate this guy. So what I'm actually gonna do, I first gonna rewrite that as 9 integral sine 3x. This is a multiple angle, right? Okay, give me 1 second. I'm gonna write that very well. Okay, so um that's gonna be sine 3x sine 3x dx, right? Now, and the next thing you're gonna do, if I integrate a sine, you're gonna first but gonna write negative cos 3x. Okay. Now after that, you come to the angle, you come to the multiple angle, and you differentiate 3x. Differentiating 3x is actually going to be 3. Then you divide that by that. Then the 9 here is going to be, parts of it. Take a look at that. So with that now, then I'm going to say plus constant. And I'm going to do 3 goes in 9. That's going to give me negative, because let's say negative here, right? Negative 3. Okay, cos 3x plus c. And that was how they got this particular answer here. Okay, if I want to go to questions, if I want to solve question 17 now, okay, if you really want to know how they got what they got, okay, in question 17, okay, if you really want to know what they do, the very first thing you do, okay, if I want to rewrite this guy now, I'm going to write 7 out. I'm going to put cos 5x dx. Integrating cos something is sine. I first write all of that. Sine 5x, right? Then I'm going to say divided by. Then I'm going to differentiate the multiple angle with respect to x. That's going to be 5, right? You know, put it right here. Then the 7 here, I'm going to write it out. And I'm going to do plus c. And that was how they got it. Look at that. That's super cool, right? That's super easy. That's how to go about it. Okay, so the next that I'm actually gonna do is I think I've been able to integrate the that so trigonometric function. Okay, so the I'm gonna do this one now. Take a look at this. I'm gonna attempt this one now. I want to attempt this guy now. I'm gonna write it for out, and I'm gonna do sine x over 3 dx. Now integrating sine is gonna be a negative cos, right? I first write negative cos that stuff. Now divided by differentiate x over 3. That will be 1 over 3, right? What about the 4? Put it 4, okay, then plus c. So if I want to write this guy here, if I have 4 over 1 over 3, that would be 12. And because of the negative, that's going to be negative 12x over 3. And that's how we got this guy here. See that now? That's super cool, right? That's super easy. Now, the next is to talk about exponential function. How do we integrate? Okay, how do we integrate exponential function? Okay, so what I'm gonna do first, I'll first show you a kind of general rule. Okay, when it comes to exponential, the general rule is actually if I have integral exponential raised to the power ks dx, where k is a constant, okay, integrating that, it's actually going to be whatever I have divided by the constant plus c plus constant of integration. So it's going to be exponential raised to the power ks divided by k. That's what we're going to have. Okay, now using the rule now, if I want to if I actually want to focus on let's say I want to say question 19. Let me go to the question now. Okay, so I want to solve question 19 now. I need you to pay attention to what I'm gonna do. I actually want to solve question 19, right? If I want to solve that guy now, so what I'm actually gonna do, I'm gonna write for integral this ds. Okay, I'm gonna write the whole of that. Then I differentiate the top. Negative 7, I'm gonna write that. Okay, then the 4 here, I'm gonna put that plus c. Okay, so finally, that's gonna be negative 4 over 7 exponential raised to power that plus constant. That's super easy. Okay, that's how we do it. Okay, so this way I'm actually gonna start. Okay, or in case you need clarification, you can actually reach out to me by email. And of course, watch out for information on Tuesday about the final exam. The final exam is actually going to be conducted on December 3rd. Okay, but like I said, on Tuesday, watch out on information, about the final exam, the mode of conduct of final exam. I'm also using this opportunity that for those of you who have a standing assignment, I think I've tolerated that enough. If you have not done it, make sure you actually complete your outstanding assignment. God will help you. Make sure you all stay safe and have a lovely day. Bye for now, everyone.